Which of the following are linear equations? I define linear equations as equations whose graphs are lines, but we can recognize them by just looking at what operations are being performed on the equation. So, on one side we have that in linear equations, we can have addition, subtraction, multiply a number times a variable. So for example, you can have 3x, and you can also multiply times a fraction. In case you were wondering, fractions are numbers, so it's the same. There are some things that cannot happen if your equation is linear. So, for example, you cannot have powers. This cannot happen. None of these can happen. You cannot have roots. You cannot have square root of x or cube root of y. You cannot have that. You cannot have multiplication of a variable times a variable. And you cannot have variables as denominators. You cannot divide by a variable, because all of these things have graphs who turn out not to be lines. They look different. They are curves. So, if we apply it to these problems that we have here in the first one, we notice that we only are multiplying 3 times a variable, 2 times a variable, and you're only subtracting, so this is linear. On the second one, you have a second power, so this is nonlinear. On the third one, you're only multiplying numbers times variables, and you're doing addition and subtraction, so this is a linear equation. On this one, you're multiplying a variable times a variable, so this is nonlinear. And on this one, you're dividing times a variable, so this is nonlinear either. You don't need to have